Okay, hello again. Here's the problem. Without looking at the graph, we just have this charted information of snowfall. Perhaps we had some snowfall in the evening last night or the early morning. So here we have at 0 times and 0 hours there was no inches per hour, and then at 4 hours it was snowing at this rate 0.25 inches per hour, and so on. So write down the chart and we'll go ahead and graph it. And if this is inches per hour and this is hours, you can see that inches per hour times hours will give us the total inches. So we're looking for the total snowfall, so it is found under the curve. So we verified that. So let's draw in our trapezoids. So we're going to find the area with trapezoids. So the first area between 0 and 4, there's a dot at each. I'm going to draw a straight line between the two. And that trapezoid actually looks like a triangle, but you'll see that the formula will work. Then the next trapezoid is between these 2 points, and the next one, and the next one. I'm just drawing sort of dot to dot and making a trapezoid under each. So you can see that this trapezoidal method gets pretty close to the curve. We're going to lose this spot, this little sliver here and here. It's very close in this area to the actual area under the curve. Still an approximation. Alright, so let's get some numbers going. Change in x is b minus a over the number of boxes. And we have 24 minus 0 divided by 1, 2, 3, 4, 5, 6. So 24 divided by 6 is 4. So the change in x equals 4. Alright, so I'm going to pull the 4 out like I did on the other problems that we did, and it will be multiplied in the end. So I'll have the width of each of my boxes already out here in front. So now I'm going to do the trapezoidal part, where we're going to have to add the height of the bases. Remember, the first one here is at 0. The second one is at 2.5. So this base and this base are added, and they're divided by 2, like the formula for the area of a trapezoid requires. So now I'm going to add the next area. It's going to go from a base of 0.25 to 0.5 divided by 2, and so on. So let's gather the rest of the information. So we have, I finished this one and this one, 0.5 plus 1.5 divided by 2 plus 1.5 to 2 1.5 to 2, 2 to 1, alright, 2 to 1, and 1 to 0.25. I may want to make an observation now about the trapezoidal rule, and I'll move my work up here since you already have the chart written down in front of you. I'm going to move my work up top here, and I'm going to make another observation. The width for of each of these trapezoids I brought out in front, and look, there's another number I can bring out in front, and that is the 2, which will always be there in the trapezoidal rule. So I actually use b minus a over, remember it was n, but there's always a 2. So in the trapezoidal rule, I go ahead and pull that out right away. So I'm going to pull that 2 out, and these will disappear from our list here. And now I have a green finger which I hope is like a green thumb. So now I have another observation here. Notice the 0 appears once in the list, but the 0.25 appears twice, and the 0.5 appears twice, and the 1.5 appears twice, and the 2 appears twice, the 1 appears twice, and the 0.25 appears once. So I'm going to indicate that by 0 appearing once, 2 times 0.25 plus 2 times 0.5 plus 2 times 1.5 plus 2 times 2 and plus 2 times 1, and then that last one is just appears once. And that also, when I multiplied all that out and added all that and multiplied it by 4 over 2, which is 2, I came up with 10.75. I haven't checked that yet, so if it's wrong, you'll have to correct me, and that will be in inches. Now, I want to make that observation into a different rule for the trapezoid. So I'm going to use this b minus a over 2n. So the area of using the trapezoidal rule is going to be approximately b minus a over 2n. And then it's going to be the x sub o used once. Then it's going to go to the x sub 1 and add it twice. Plus twice the x sub 2 plus dot dot dot. Plus twice the x sub n minus 1 plus 1 times the x sub n. So that's another way to think of the trapezoidal rule, and it always works. So that's what I'm going to leave you with right now. I want you to get a calculus book. I know you have one downstairs in your locker, Bailey. And I want you to open to section 4.6. And until I get there, I'm going to assign you 4 problems, but they are kind of written in a different way in your calculus book at that point, because they taught the trapezoidal rule in a different spot. They are going to have a problem that looks like this: the integral of x squared dx from 0 to 2. And that's in 4 boxes like that. So what I want you to do with that, and that's number 1 on 4.6, and I want you to do numbers 1 through 4. But what I want you to do here is think of this as y equals x squared on the interval from 0 to 2, and n is 4 boxes, or 4 trapezoids. So this is what I mean for you to do from this. And I want you to use the trapezoidal rule in the most convenient way that I've shown you, and it's right there. Alright, so go ahead and try that one. I'll give you the answer to the first one and see if you guys can get it. 2.75. And so set up your trapezoidal rule. Draw a sketch of y equals x squared between 0 and 2. Divide it into 4 boxes, 4 trapezoids. And then use this trapezoidal rule. So I'll be there in a bit and check on your progress, and we'll talk about last night's homework and some other old business. So I'll see you in a bit. Bye.